So in the previous session we have seen about amplitude modulation, where the amplitude of carrier wave is modulated or modified. So the carrier wave we have considered is this. The modulating wave sin omega mt, and the amplitude of the modulated wave is given by the original amplitude plus the modulating signal. So the amplitude oscillates. So the total modulated wave is given by so here we are not altering the frequency and we are not considering phase at all because we are not dealing with it. All we are dealing with is the amplitude. Okay, so if you take VC into common, you can write it as so that is the total signal. So here m value is in between 0 and 1. Right. So this function, when you complete the multiplication, what do you get? So this is given by Vc sin omega ct m times Vc sin omega mt sin omega ct. So if you take sin A sin B formula, can be written as Vc sin omega ct plus half mVc cos omega c minus omega mt minus cos omega c plus omega m. Cos a minus b minus cos a plus b. Because omega c is assumed to be higher. Frequency of carrier wave is larger. Whatever we have, I mean, even if you take omega m minus omega c, cosine is a symmetric function. Negative sign will not come out of it. So in total we have the carrier frequency and a frequency less than the carrier frequency and a frequency higher than the carrier frequency. So to avoid these confusions like one is cosine term, another is sine term and all, it is more convenient to consider all cosine terms. Like if you consider EC is equal to Vc cos omega ct, Em is equal to Vm cos omega mt, and V modulation Vc plus Vm cos omega mt, so that E modulated wave is given by this. So in total it is Vc 1 plus m cos omega mt cos omega ct. So here same definitions will work out, and if you expand this, what you get is Vc cos omega ct plus Vcm cos omega mt cos omega ct. So when you have cos A cos B product, the result is cos A plus B by 2 cos A minus B by 2. So the result is Vc cos omega ct plus Vcm by 2 cos omega c plus omega m t plus cos omega c minus omega m t. Cos A cos B is cos A plus B by 2 cos A minus B by 2. Right, so here you have the carrier wave frequency and a higher frequency omega c plus omega m and a lower frequency with amplitudes Vc Vcm by 2, and yeah, that's all. So for the time being I am assuming m is equal to 1, implies maximum modulation. So then what are the possibilities? Vc cos omega ct plus Vc by 2 cos omega c plus omega m t plus Vc by 2 cos omega c minus omega m t. So if you take the frequency graph, you have one line at omega c with amplitude Vc and another line at omega c minus omega m with amplitude Vc by 2, another line at omega c plus omega m with amplitude Vc by 2. You have three bands: Vc, Vc by 2, Vc by 2 amplitudes, omega c minus omega m, omega c plus omega m, and omega c. Now comes the power. Power is given by voltage square by impedance. Voltage square by impedance is the power. So if you take square of that individual terms, means you have to consider you have to integrate each term from 0 to 2 pi. So if you integrate cos omega t from 0 to 2 pi, cos omega c plus omega mt from 0 to 2 pi, you will get half. Cosine function, average of cosine function is, so I am considering average power. So I have to take average over the complete cycle. So if you take average of a cosine function over a complete cycle from 0 to 2 pi, you will get 1 by 2. Square of, if you integrate cos square omega t from 0 to 2 pi, you get 1 by 2. Cosine square function means everything will be in positive quadrant. So you will be left with something like that. This is cos square function. So if you take average over it, you will get half. So the total power is now this Vc square by 2z plus Vc square by 8z plus Vc square by 3z. Means 2 into 4z. So if you take the power in the carrier wave, it is Vc square by 2z. Then P modulated wave power is P carrier plus P carrier by 4 plus P carrier by 4. The power carried by the carrier wave is considered separately. In terms of the power of the carrier, each sideband carries 1/4 of the power equivalent to carrier. Okay, so carrier, each sideband requires only 1/4 of the total power of the carrier. Now comes what are the possibilities? Like entire information is in this modulating wave, right? All we need is omega m information, right? Whatever we speak will be recorded in that. So information is now carried only by these side bands. Carrier wave does not have any information that we wish to transfer. మనం ట్రాన్స్మిట్ చేయాలనుకున్న ఇన్ఫర్మేషన్ ఏది కూడా క్యారియర్ వేవ్లో ఉండదు. ఎంటైర్ ఇన్ఫర్మేషన్ ఈజ్ క్యారీడ్ ఇన్ side bands only. That too, one sideband is sufficient, right? Any one sideband. So there are different types of transmission modes. One is DSBS, double sideband suppressive carrier. So one mode is double sideband suppressive carrier. suppress the carrier and transmit only 2 sidebands. Total is 1.5 P carrier. So DSP-SC requires only 0.5 P carrier. If you transmit both the sidebands including carrier, it is 1.5 times P carrier. DSP-SC requires only 0.5 times P carrier. And another type is SSB. Single sideband suppressor carrier. This requires only 0.25 times carrier power. Third possibility is vestigial sideband. Single sideband. So vestigious means the one which is suppressed, partial, which was at full potential earlier. The one which is suppressed partially, which was at full potential earlier. Okay, earlier full potential ఉన్నది suppress చేస్తే it is called vestigial. This is used in TV communication. It is used in TV communication. So where one sideband is used for audio. So in vestigial sideband we use one sideband is transmitted completely, another sideband is transmitted partially. I mean with lower potential. So this will have power requirements of around 0.3, depending on between 0.3 and 0.5, 0.25 to 0.5. It is more than 0.25 and less than 0.5 power requirement. So this is widely used for analog TV communication, where one sideband is used for video signal. This partial sideband is used for audio signal. Okay. So that is about amplitude modulation. Demodulation and frequency modulation, these things we will see in the next session.